right, let's go ahead and get started here. Page 14, your homework, you had numbers 12 through 18 even. Also on page 15, numbers 24 and 26. Let's go and see how you did on those. Make sure we're thorough, using equal sign, using the symbols there for the correct angle, which I think was angle A in each case because they were boring like that. But number 12. 12 through 18 even.
What I did, I was like 14.
See, what had happened was...
I read the homework. I did everything.
Except number 12, yeah.
I can help you do 12.
Why don't you get your calculator out, Ethan, and let's do number 12 together, Ethan.
Yes.
Start by finding the length of the hypotenuse, Ethan.
Alright, fine. I'll find it. 190.39.
Right, so for the hypotenuse, we should get 190.39, blah, blah, blah. But we're going to round that off to how many significant figures for number 12?
3.
Well, look at the given numbers. I got 75 and 175.
2.
All right, so round it off to 2 sig figs.
190.8.
Well, if I put the point, that's 3. We're going to talk about that in physics later. But if I put the point, that makes the 0 significant. So we'll just say 190. And what units?
Inches.
Inches. So this should have been the first answer we got, was the length of the hypotenuse. Did you all get 190 inches? All right, now that we've got it, though, we're not going to use the 190. We're not even going to use 190.39. We need to put this in the memory of the calculator. And we're going to use that to find the sine of alpha, the cosine of alpha, the tangent of alpha, the cotangent of alpha, the secant of alpha, and the cosecant of alpha. Ethan, sine is what over what?
Opposite over about.
So in this case, we're going to divide the
75 over that memory.
75 divided by memory gives us?
0.394.
Good. So fix that calculator, three decimals, not 3 6 figs, 3 decimals, get 0.394. And once we get the sine, we should also go ahead and get the, using the reciprocal button. There we go. And what do we get for the cosecant?
2.539.
2.539 is correct. Then we're going to get the cosine. Cosine's what over what?
Jason over hypotenuse.
So there's the 175 over the memory to give you?
100. It didn't divide. Hold on.
Yeah, let's try 175 divided by, recall 1.
0.989.
And once we have the cosine, we'll go ahead and hit the reciprocal button to get the secant, which is
1.088.
And then we'll go ahead and get the tangent. Tangent's what over what?
Opposite over adjacent.
Opposite over adjacent, and that'll be the 75 over 175 gives us
0.429.
And once we've got that, we'll use the reciprocal button to get the, which is
3.333.
And there we go. All right, the rest of you, did we get these answers for number 12?
I just got the cosine wrong.
Just the cosine wrong. But you somehow got the secant right?
The secant's 1.088.
What did you get for the cosine?
0.921.
0.921. Did you have the fix on your calculator?
I might have.
You do. That's really strange. How you could have possibly gotten the secant right and the cosine wrong.
She didn't have the fix on because I did it without the fix and I got 9. No, not right now, but like with the first time I did it and I knew it was wrong because I forgot to put the fix on. Without fix, it is 0.921. But with the fix on, it is.
No, it'd still be 0.919. It's just you might accidentally round wrong in your head if you didn't have the fix on. That's all that would happen. Let me go and give you the answers to numbers 14, 16, and 18. Check your answers. Number 14, the missing leg, the opposite across from beta, should have been 9.7 yards when we rounded 2 sig figs. But 9.746 blah, blah, blah is what goes in the memory of the calculator. For the sine of beta, 0.812, cosine, 0.583, tangent, 1.392, cotangent, 0.718, secant, 1.714, and cosecant, 1.231. I'm going to get all 7 answers correct on 14. Only Ethan. Did we get the right leg? 9.7 yards.
I know what I did.
So we missed the leg, so we're doomed, okay? You know what you did?
I swapped my cotangent and cosecant.
Swapped cotangent and cosecant. Careful. Cotangent, the reciprocal of tangent. Cosecant, the reciprocal of sine. Make sure we keep those straight.
I got 14.
For what?
For the missing.
You treated it like you were finding the hypotenuse then, instead of finding a leg. So you squared and added instead of squared and subtracted and then took the square
By the
root.
way, I know how she got 0.921 now. She didn't put it in her memory.
Well, that was my other thought, is maybe she didn't use the memory, maybe she used a
Just
rounded
190 by
value.
itself gives you 0.921.
Ah, maybe that's what happened then. Did 175 divided by 190 instead of 175 divided by memory
Call me
value.
Sherlock Holmes.
You're not teaching.
Alright, number 16. Missing a leg should have been 51 miles. 51 miles for the missing leg. If you got something bigger than 85, you treated it like you were finding a hypotenuse. Instead of squaring and subtracting, you squared and added. So all the answers will be wrong. If you did not, get 51 miles for the leg. Now, your sine of gamma, okay, that's your lowercase gamma there. Sine of gamma should be 0.600, cosine is 0.800, tangent of gamma is 0.750, cotangent of gamma 1.333, secant of gamma 1.250, and the cosecant of gamma is 1.667. How many got all of those correct for 16? Only Ethan again. Jamie?
I got the leg wrong.
Got the leg wrong, so you were doomed.
Same thing.
Leg wrong. What did you get for the missing?
No, I switched my cosecant.
Oh, same thing as the last time, not same
I
thing.
keep doing it.
Jamie, what was your leg?
My leg I had 110.
Okay.
109 for my leg.
Right, so you just, again, make sure we know, are we finding hypotenuse or are we finding leg, and be careful accordingly. Number 18, we really are finding the hypotenuse this time. And so when we found the hypotenuse, you got 18.7 meters. I trust you two got that. Since you were missing the last one, 18.7 meters. For the sine of alpha, 0.471, cosine is 0.882, tangent is 0.533, cotangent 1.875, secant 1.133, and the cosecant 2.125. Be perfect on 18, or once again switch the cotangent and cosecant. So gotta keep them straight. Who goes with who? Sine, cosecant, cosine, secant, tangent, cotangent. Go
My
together.
sin and secant.
All right, questions on those?
My sin and my SEC was wrong.
Cosecant, you mean?
Yeah.
All right. Opposite over hypotenuse should have been 8.80 divided by that memory of the 18.7-ish.
I just got 0.470 instead of 0.471. I think I rounded wrong.
Probably, and again, if you have the fix on, you don't have to worry about the rounding. All right, look over across the page. Page 15. Take a look at number 24. We were given the cotangent of angle A is 3 to 4. And we need to think here, well, cotangent. Cotangent gives me two sides of the triangle, or at least the ratio of two sides of the triangle. But cotangent's not one of our special SOHCAHTOA functions or ratios, right? But cotangent is the reciprocal function of tangent. And tangent is one of our SOHCAHTOAs. Tangent's what over what?
Opposite over adjacent.
Opposite over adjacent, which means cotangent, the reciprocal must be adjacent over opposite, which means we know the two legs, therefore we must find the hypotenuse. And wait a second, 3, 4, 5 Pythagorean
I remember
triplet.
that.
Or you could use the Pythagorean theorem to get the 5. Once we've got it, we can find the sine, cosine, tangent. We don't need the cotangent, it's already there. Secant and cosecant of angle A. Of course, the easiest one to get is the tangent, because you just take the reciprocal class, 4 over 3. For the sine, though, opposite over hypotenuse,
0.9.
4 over 5. For the cosine, adjacent over hypotenuse, 3 over 5. For the secant, which is the reciprocal of cosine, we'll get 5 over 3. And cosecant, which is the reciprocal of sine, we'll get 5 over 4. And these should have been our answers for number 24. Questions on 24.
I mean, I know what I did. I turned it into decimals instead of giving it fractions.
All right. Yeah, here we wanted exact values as opposed to the decimals. And similarly on number 26, they give us the cosine of angle A is 5 to 6. And this is one of the big three, SOHCAHTOA. Cosine's what over what, Chris?
5 over 6.
In general, cosine's defined as what over what?
Opposite over adjacent. No,
Class.
opposite over hypotenuse.
Adjacent over hypotenuse, there we go. And I'll leave some room here for my cotangent. The epitome of lazy. All right, so we know this is adjacent over hypotenuse, which means, class, all we're missing is the opposite leg. Use the Pythagorean theorem to find the opposite leg, but we don't want a decimal. So we're going to square and subtract because we're finding a leg, and we end up with the square root of 11. We're just going to leave this radical value. So when we talk about exact values, that means leave the radicals, leave the fractions, no decimals. Sine is what over what, class? Opposite over hypotenuse. So in this case, the square root of 11 over 6. Tangent is what over what? Opposite over adjacent. So in this case, the square root of 11 over 5. Of course, we already know the cosine's 5 over 6. Cotangent, class, is the reciprocal of tangent. Well, tangent's square root of 11 over 5. This is going to be 5 over the square root of 11. But, Jamie, I got to rationalize.
And make it 5 times the square root of 11 over 11.
There we go. Secant, class, is the reciprocal of
Cosine.
secant is the reciprocal of cosine. Remember,
It's confusing me not having the other one there.
because the cosine's not there. Okay, but that's why I said memorize it. Sine, cosecant. Cosine, secant. Tangent, cotangent. Each plane function goes with a co for its reciprocal. So sine and cosecant. Tangent and cotangent. Secant and cosine. You just got to memorize which ones go together. All right, so secant here is going to be the reciprocal of the cosine, so class it's going to be 6 over 5. And cosecant, of course, the reciprocal of sine is going to be 6 over the square root of 11. Well, of course, we'll rationalize that, Ethan.
6 times square root of 11 over 11.
6 times the square root of 11 over 11. Questions on this? You've got to memorize those relationships, those reciprocal identities. Set your books aside for now. Keep your notebooks out. Let's do some classwork review together. And suppose we have a right triangle here, where this acute angle is twice that one. We know the hypotenuse is 8 feet. Find the other two sides. We also have a right triangle with two equal acute angles. And again, a hypotenuse of 8 feet. Find the other two sides. Then if we've got a right triangle in which side A is 4.5 centimeters, side C is 7 centimeters, find side B, and then find all 6 trig ratios of angle A. You may want to draw a picture for that last problem.
I have a question.
Yes, sir.
So when it's the hypotenuse that is the only one we know is the hypotenuse, we automatically assume that the opposite is 1, right?
This angle's twice that way. you know the two acute angles are complementary. And if one of them's twice the other, how big are those two angles? 60 and 30, which means it's a 30, 60, 90. Which means the sides always have a specific ratio. How can we represent the hypotenuse of any 30, 60, 90 class?
X times square root of 30.
Oh,
2x.
2x. How do we represent the long leg across from the 60 in any 30, 60, 90 class? X times the square root of 3. How would we represent the short leg across from the 30? X. So if 8 feet is 2x, then what's x? 4 feet. And what's x times the square root of 3? 4 times the square root of 3 feet. And there's the two answers.
I had it mixed up. The X times square root of 3 and 2.
Hypotenuse is double the short, long leg. Because remember, 2 is bigger than square root of 3, right? Square root of 4 is 2. Square root of 4 has to be bigger than square root of 3. And hypotenuse is always the biggest. So if you got them backwards, that's illogical. Do you see that? Right? So, but that might help you remember which one's the 2x and which one's the x squared of 3. What about in a 45, 45, 90, right? Two equal acute angles makes them each 45, hence 45, 45, 90. How do I represent the hypotenuse of a 45, 45, 90 class? X times the square root of 2. How do I represent this leg? X. How about this leg? X. So if 8 is x times the square root of 2, then what is x? 8 divided by the square root of 2. But we want to rationalize that down. What would we get? 4 times the square root of 2 feet. And of course, if that's x, that's also this x as well. All right, finish working. Just another minute or two to finish up.